Okay, so we're going to talk about how to find the derivatives of exponential functions. I think needs to be changed. Okay, so if you're trying to find the derivative with respect to x of b to the x, it will equal b to the x times the natural log of the base. Okay, if it's more complicated than that, or you have b to the u, it'll be the same thing, but it'll be b to the u times natural log of b, and then apply the chain rule, so times the derivative of u. Okay, and this is really nice. The derivative of e to the x is just e to the x. If you have e to the something more complicated, it'd be e to the u times the derivative of u, applying the chain rule. Okay, so let's do some examples. Okay, so number one, f of x equals e to the 3x. Okay, so the derivative of e to the x is just e to the x, right? So the derivative of e to the 3x is just e to the 3x, and then chain rule, so times the derivative of 3x is just 3. And you can just move that 3 to the front to be a coefficient, and that's it. Okay, number two, we could rewrite this to be e to the x to the 1/2. So when we're taking the derivative, we know how to apply the chain rule. So, okay, the derivative of e to the square root of x is just, that. Same thing, and then times the chain rule, right? So times the derivative of x to the 1/2 is just 1/2 x to the negative 1/2. And you could rewrite this to be e to the square root of x over 2 square root x. Okay, all right, number three. Okay, so the derivative of e to the 2x minus 1 would be the same thing. Chain rule, so times the derivative of 2x minus 1 is just 2. And again, I would just move that 2 to the front. Okay, okay, number four, we could rewrite that as e to the negative 3x to the negative 1. So again, when we do the chain rule, it's easier to see what to do. Okay, so the derivative with respect to x would be, the same thing, right? E to the negative 3 over x times the derivative of the exponent, which is, negative 1 times negative 3 is 3. And then x to the, subtract 1 off the exponent, so negative 2. And just to rewrite it with positive exponents, it'd be 3 over, and then e, well, we can put x squared in front. It doesn't matter, but x squared, and then e to the 3 over x. So positive exponents. Okay, so 5, okay, so this is something with a base different than e. So dy dx equals 2 to the x times the natural log of the base. And that's it. Okay, so 6, also a base different than e. So we're just going to follow the same rule that we just used. So it'll be 7 to the 3x plus 1 times the natural log of the base, 7. And then chain rule, so times the derivative of the exponent, so times 3. And that's a good answer. You can't do anything with that. All right, so here on 7, we have to apply the product rule. Okay, so what is it? The derivative of x squared is 2x times e to the negative x plus x squared times the derivative of e to the negative x, right? So that's just e to the negative x, and then chain rule, so times the derivative of negative x is negative 1. Okay, so we can clean it up a little bit, right? Or sometimes you can see this in factored form. So dy dx equals, what could we factor out? X and an e to the negative x. And what's left is 2 minus x. Okay. Let's see. Okay, number 8. I would suggest rewriting this instead of using like the quotient rule to be 1/2 e to the x and then minus 1/2 e to the negative x. Okay, and then we can just take the derivative from there. Okay, so the derivative of 1/2 e to the x is just 1/2 e to the x. Okay, the derivative of minus 1/2 e to the negative x would be, the same thing. And chain rule times the derivative of negative x is -1. Okay, so let's see. So the minus times the -1 is a plus. So that's a good answer. Or you could see this as like one fraction where it's all over 2. Like that. Okay, on 6 we want to apply the chain rule as well. Not the chain rule. I meant the product rule. We might have to do the chain rule on 6 to the -2x. Okay, the derivative of x is just 1, right? Times 6 to the -2x plus x times the derivative of 6 to the -2x, right? Which is this, and then times the chain rule, so times the derivative of -2x, which is -2. Okay, and then we just simplify from here. All right, and so that's a good answer. Or you could see this as where they factor something out. Like that. So that's a good answer. Okay, 10. Okay, the derivative would be 3. The derivative of e to the cosine x is e to the cosine x times, chain rule times the derivative of cosine x times negative sine x. And that's a good answer, but I try to clean it up a little bit. So y prime equals -3 e cosine x to the cosine x and times sine x. Okay, and then on 11, instead of taking the derivative right away, because you'd have to use chain rule and quotient rule, so we'll do what we did last lesson. We will first use log properties to separate this into 2 logs through subtraction. Okay, now we can take the derivative. Okay, so the derivative of natural log of 1 plus e to the x is 1 over 1 plus e to the x times the derivative of 1 plus e to the x, which is that. Okay, minus the derivative of natural log of 1 minus e to the x. So it'd be 1 over, the argument, times the derivative of 1 minus e to the x, right, for chain rule. So that'd be negative e to the x. Okay, and we'll just clean it up a little bit. So we'll put everything in the numerator. And then the minus and negative makes it a plus. Yeah, that's a good answer. Okay, on 12, we're going to apply the product rule. Okay, so the derivative of 5 to the negative x over 2 would be 5 to the negative x over 2, the same thing, times the natural log of the base, right? Times the chain rule, right? Times the derivative of negative x over 2, which is -1/2. Okay. Times the other function, sine 2x. All right, plus, right? So now the second part of the product rule. Okay, so 5 to the negative x over 2, not changing that, Okay, times the derivative of sine of 2x, which is cosine of 2x, and then chain rule. So times the derivative of 2x is 2. Okay, and that's a good answer. Or, you could see it where they factor out the 5 to the negative x over 2. Okay, moving on. 13. Okay, so find an equation, the tangent line to the graph at 2, 1. Okay, so right here, so we're trying to find the equation, okay, of that line. So first thing, find the derivative. Okay, so dy dx. Okay, so it equal, since it's exponential, it's the same thing, times the natural log of the base. And, like chain rule, times the derivative of x minus 2, which is 1. So you don't need to write that. So we want to evaluate the derivative at 2, 1, right? So we'll just plug in 2 wherever there's an x. Okay, so 5 to the 2 minus 2, that's 5 to the 0, right? Times natural log of 5, which is just 1 times natural log of 5. Okay, so the slope of that line is just natural log of 5. Okay, so what's the equation? So the equation is y minus 1 equals the slope, natural log of 5, times x minus 2. All right. All right, moving on to 14. Okay, find the equation of the tangent line to that graph at 2, 1. Okay, so, we're trying to find that line. All right, so first thing, find the derivative. So since it's exponential, the derivative would be the same thing, times the chain rule, times the derivative of the exponent. So that'd be negative 2 plus 2x. All right, and then we want to evaluate the derivative at 2, 1. So we just want to plug in 2 for x. Okay, so this will get you e to the 0 and times, what is that, 2? So that's just 1 times 2, which is 2. Okay, so the slope of the line is 2. So the equation is y minus 1 equals 2 times x minus 2.